Hello world and welcome to another video. Let's solve the problem of converting a linked list to an array. Feel free to pause the video and read through what the problem is asking for, but I find the examples a lot more descriptive. Given a linked list, like in this case, we want to return an array that contains all the values of the linked list in the exact order, but we want to do this recursively. As always, here's the solution and here's how it works. First, you define a function and you pass in the head of the linked list. In this case, this happens to be our node A. Since this is a recursive solution, the first thing we do is check what we call the base case. In this case, we check if head is pointing to null. In this case, head points to A, so we skip the base case and we go ahead and open up an array and add head's value and then call the function recursive on himself. For now, ignore what the asterisk does. It's called the spread operator and we're going to dive into details of what he actually does. Since we call the function recursively on himself, passing in head.next, in the next recursive execution of this function, the head essentially becomes the B node. Next, we check the base case again. Does head currently point to null? No, he doesn't. He points to the B node. So we add the B's value into this array and call him again recursively on himself, passing in head.next, which happens to be C. Now that our head is effectively on the C node, we go ahead and check again. Does head point to null? Base case doesn't get triggered because head doesn't point to null. So we go ahead and add the C value and call him recursively on himself using head.next, effectively making D the head of the next iteration. At this point, I think you kind of get the gist. We're just going to keep repeating this until head points to the null. We have all our values in the array and our head currently points to null. So for our last recursive call, we check, does head point to null? In this case, yes. So we return an empty array. This function has a time complexity of big O of n. This is because we have to iterate through each element in the linked list. For space complexity, it's big O of n cubed. And here's why. The first n is because we have an array with n elements in it. The second n is because of the spread operator. Each time we're creating a new array and copying elements of that array and putting them into this array. And the third n is because arrays or lists in Python are immutable, meaning each time we append a new value into this array or this list, we have to create a copy of him in memory and append to that copy and point to that copy we made. So in this case, we're going to be making n copies of this array or this list. Again, keep in mind, big O takes account for worst case scenarios, not optimal case scenarios. As always, this is a function on the code editor. Typically, you'll be given a linked list, but in the case you're not given one, here's how you create one. As we know, the node is the building block of a linked list. So here we're creating 5 nodes, and here we're connecting the links to each of the nodes. So once you run this code, you would have a linked list exactly like this. We run our function and we return an array with each of the values. So that's it for the video, guys. I hope it was helpful and I'll see you in the next one.